Hello and welcome to our lesson on radicals explained, part 1. First of all, let's talk about the definitions. A radical is an expression, so it doesn't have an equal sign, that includes a number and sometimes also a variable. A radical, it's also called a root sign, and an index, and you can see right here. The index is right there, it's the teeny tiny number. The radicand goes underneath the radical sign. Now, there are the three parts which we just talked about. First is the radicand. It's this number right here. It's the number, or variable too, that you are taking the root of through prime factorization. And we'll talk about that prime factorization in just a minute. Second part is the index. And that index is that teeny tiny number outside the radical sign. The index is the number of factors in the group that you need to take out of the prime factorization. Again, we'll show that in just a minute. And then the third part is the radical sign. It's that funky looking check mark. And it's the drawing that goes above the radicand, and it resembles the big check mark. It's also sometimes called the square root sign if that teeny tiny index number is a 2. Otherwise, it's just the radical sign. Now, we talked about prime factorization. So the first thing that you need to do is prime factorize the radicand, which is this 96 right there. So in other words, what are the prime numbers that can all multiply together to create 96? And remember, a prime number is any number that can only be broken down into 1 in itself. Multiplied to create it can only be 1 in itself. That's it. So this would be an example of a prime number. Another one would be 3 because it's 1 times 3. Another prime number would be 5 because it's 1 times 5, and so on. Not all odd numbers are prime though, because think about 9. 3 times 3. That's not a prime number. Okay, now, going back to starting with the lovely 96, and we're going to break it with a prime factorization tree. Some of them call it a square root tree or a root tree. 96, you can start anywhere. What two numbers create 96? I know that 3 goes in there evenly, and it goes in 32 times. 3 is now a prime number, so I can stop with 3, I'm good. But 32 isn't a prime number, so I have to break it down some more. And I know that 8 times 4 is also 32. You could break it down any way you want. 8's not prime, so I still have to go more with that. 4 times 2. 2 is a prime number. And I keep putting dots under the prime numbers so I can keep track of them. And then 4 gets broken down into 2 times 2. Now, I still have this 4 sitting over there, and he's not prime yet, so I got to break him down again. 2 times 2. And look at this. I have 3, 2, 2, 2, 2, and 2. I've got 5 2's and a 3. Now, what we need to do is circle all the prime numbers that appear in groups of 4. Why 4? Because that's what the index is telling us. So if we go through and we look at that, they're asking us to go and circle groups of 4. There's a group of 4 2's. And we still have the prime number 2 and the prime number 3 left over. So take a look what happened. See that whole number 2? Because we had 2 times 2 times 2 times 2 times 3, and we circled them in a group of 4, what it's saying is that one group of 4, it's a group of 2's, so it comes out just as 1 2. This whole number is telling us that it's a big group of 4 2's, because that's what the index told us was 4. And then this right here is our leftover, so that means that we have to multiply 2 times 3, and we get 6, and it goes right back under the radicand sign, or it goes right back under the radical sign, becomes your new radicand. To double check your answer, you're going to multiply that whole number 2, that's sitting out there, the number of times in the index. So you need to multiply 2 4 times in a row. And it's 4 because that's what our index was. So 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is 16. Now you have to multiply that answer, our 16, by the radicand, which is 6. Remember, we got him right up there. So now we're going to take 16 and multiply it by 6. And if we do that, we should get 96. And if you remember, does it match the original radicand? Let's go back and look. Yes, the original radicand was 96. So that means our double check is correct. Our answer is correct. So all this stuff right here is a correct answer. What does all this mean? The answer to the radical expression explains how many times you can multiply that outside whole number, that 2, using the index as a guide. So we're multiplying the 2 by itself 4 times in a row. The leftover inside the radicand, inside the radical sign, that 2 and that 3, are the ungrouped ones. They couldn't make up groups of 4, so we left them behind. We multiplied them together, and they became our new radicand. Why would we have to do this, and where are you going to see these things? They're everywhere. It may seem useless, but you're going to see them in Algebra 1, you're going to see them in Algebra 2, Geometry, and a bunch of upper-level courses like Calculus, Pre-Calculus. So just to name a few, you're going to also see them in quadratics, in the rational root theorem, in factoring, and many other things. If you can get radicals down and make it easy and understand it, and you can get them right, and you can get them quick, it makes the math get so much easier the more you take through high school. A radical expression has 3 parts. It's got the index, that teeny tiny number, the radicand, which is the number underneath the radical symbol, which is the check mark. The radicand is the number that you need to break down by prime factorization. Remember, we took the number 96 and we broke it down. The index, that teeny tiny number 4 that we had, is the grouping of numbers from the prime factorization calculation. In other words, once we got all our prime numbers, the 2 times 2 times 2 times, and it kept going, we had to group them in groups of 4, because that's what our index told us to do. Any leftover numbers that couldn't be grouped into groups of 4, according to our index, that 2 and that 3, they got multiplied together. They created 6. And then we put them right back under the radical sign, and they became our new radicand. And that's it for Radicals Explained, Part 1.